Welcome to this Algebra 2 session on function equations. So what we're going to do today is draw graphs of absolute value functions, determine domain and range, and/or determine the coordinates of the vertex. Determine equations of absolute value functions given the graph or information about the graph. What we're going to start with, though, is a little lesson here on notation. Oftentimes math has a variety of ways to say the same thing. So if you look at all of these notations, you're going to see them in your lesson, you'll see them on your quiz. They all are the same, they all say the same thing. The equation you're looking at is x squared plus 7. It's just the notation changes as you go down through here. This is y equal to x squared plus 7, f of x, that's the way we read that, equals x squared plus 7. The arrow here is red, is mapped to. So x is mapped to x squared plus 7. Same thing here. You could say f of x is mapped to x squared plus 7. F is equal to the order pair xy such that y equals x squared plus 7. These are probably, let me see here, these three are the ones that you're going to see the most, these three. So if you need to pause, you can do that. So what we're asked here is to evaluate the function f of x equal to 4 plus x divided by 5 for f of negative 5. So what that's telling us is to replace the x in the function with negative 5. So when I do that, this is just notation here on the left, guys. F of negative 5, that's just a notation. It's telling me replace the x with negative 5. So what I'm doing is 4 plus negative 5 divided by 5. That gives me negative 1 on top over 5. So my answer here, or from evaluating, I get negative 1/5. And then moving on here, let's look at a different notation. H of x is mapped to 2x squared minus 3x plus 6. So again, we're taking 2.5 and we're replacing the x in the equation, h of x. So what we will have is 2 times 2.5 squared minus 3 times 2.5 plus 6. And all you need to do is make sure that you follow your order of operations. 2.5 squared is 6.25, so I'm going to do my exponents first. And then, if we want to keep going with the steps here, multiplying 2 times 6.25 gives me 12.5, minus 3 times 2.5 gives me 7.5, plus 6. Go in order from left to right, and I'm taking 12.5 minus 7.5, and that gives me 5 plus 6, which is 11. Alright, moving on, we're going to look at some graphing here. We're going to graph y equals the absolute value of x plus 2. So the first thing that you should do is find your y-intercept. So I'm going to change to a different font here, or a different size. So finding my y-intercept, remember we make x 0 in the equation. So that gives me y equal to the absolute value of 0 plus 2. And that is y equal to 2. So 0, 2 is a point I can put on my graph here. Now, if you've looked at the lesson so far, you may not have. This is going to be the bottommost point for your graph. So your y-intercept, with what we're doing right now, is going to be the bottommost point of your graph. In absolute value functions, you'll notice the note down here, they have a V shape. Okay, they have a V shape. So it's going to look like a V when you graph it. And when you're making a table, you can make a table for it. I should have put this in the notes as well. Use positives and negatives. So if you're going to make a table to get an idea of what this looks like, use positive and negative numbers. Okay, so if we do, let's do -2, -1, we already did 0, 1, and 2. So if we put -2 in, we get the absolute value of -2 plus 2. The absolute value of -2 is a positive 2. So 2 plus 2 gives me 4. Sorry about that. So we get -2 and 4 for on our graph. Then putting -1 in, we get the absolute value of -1 plus 2. So that'll be a positive 1 plus 2, which is 3. So -1, 3 is another point on our graph. Putting 1 in, we have the absolute value of 1 plus 2, gives me 1 plus 2, which is 3. So I get 1, 3 as a point on my graph. And putting 2 in gives me 2 plus 2, which is 4. Okay, so this should be enough points to help us see what this is going to look like. Let me go back to a bigger font here. All right, so putting the points on, -2, 4, and -1, 3, and 1, 3, and 2, 4. So you can see it's already taking a V shape. So we can connect it. And you have your graph. So we will get into variations of this, but for right now, you're going to have a V shape like this, and it's going to open up. So make a table. That's your best thing to do. Use your positives and negatives when you're graphing it. Let's quickly talk about what the domain and range is here, since we did that last lesson. The domain, remember, what you're asking yourself is, are there any restrictions on what I put in for x? Can I put anything I want in here for x and get an answer? And the answer to that is yes. So that tells us right away that the domain is all real numbers. Then the range, are there any restrictions on my range? Well, if you look at this, looking at your graph, you can see that on the y-axis, this is our starting point, and our y values go up. So we do have a restriction because we don't have anything in the negative area down here. And we wouldn't expect to because we're taking absolute value here, although we are adding a number to the end. So if you're subtracting a number from the end, you should be okay. So putting in for the range then, we have y is going to be greater than or equal to 2. And notice that this number matches my y-intercept here. So you don't even have to have a graph really to calculate your domain and range. So you want to keep that in mind when you're doing these. Now, you want to take note, too, that you may go down here into the negatives depending on if you're adding or subtracting a number on the end. So just keep that in mind. All right, so, but remember, absolute value of a number is always positive. All right, moving on here. Graph y equals x squared minus 3. The first thing we're going to do, once again, is find the y-intercept. So we make x equal to 0. So we get y equal to 0 squared minus 3, and that is a -3. So our intercept here, y-intercept, is at -3. Now you'll notice the note I have down here, the squared graph will have a U shape. So if you're taking x squared, if you're graphing x squared, it's going to have a U shape. So when you make your table, you want to do the same thing again, pick positive and negative numbers, because as you probably noticed, and I didn't mention, with absolute value, it's symmetrical. You have a mirror image. So the same thing happens here with the This is actually called a parabola. Your squared graph is also a mirror image. So we're going to put values in for x. So let's do, again, -2, -1, 1, and 2, since we already did 0. So that gives us -2 squared minus 3. Make sure you're squaring the -2, which is a +4 minus 3, which is 1. So we get -2, 1 for a point. Putting -1 in and squaring it, minus 3, gives us 1 minus 3, which is a -2. So -1, -2 is another point. Putting 0 in, we already did that. Putting 1 in, 1 squared minus 3 will be 1 minus 3, which is a -2. And then last but not least, putting 2 in will be 4 minus 3, which is 1. So graphing this on our coordinate plane will give us, let's put it in a bigger font here, -2, 1, -1, -2, it's right here, and then 1, -2, and 2, 1. And connecting it, it's going to be a Y shape, as I said before. And that's your graph. All right, so we are going to talk very briefly about putting this in your graphing calculator. Now, I have not talked about graphing on the graphing calculator up to this point, I don't believe. So this will be the first time we're doing this. So if you want to pause to take notes on how to do it, please do that. Okay, so you should be able to see the graphing calculator here in a second. All right, so what we're going to do is you select y equals, which is the top left, y equals. And you're going to type in x. X is, it says xt, a circle, which is theta and n, next to your colored keys. And we're squaring it. So we want the squared key diagonal to your 7. And we are subtracting 3. What you do then is hit graph in the upper right corner, and you can get a graph of what this looks like. So you have a general idea of what you're looking at when you graph this. All right, so again, y equals x by your colored keys, squared diagonal to your 7, minus 3, graph, and there it is. All right, and we may even have an absolute value, but I'm going to have to look for it. So we're not going to look at that today. When we get more into the absolute value function, we'll talk about ways to graph it on the graphing calculator. All right, last but not least, let's talk about this one. Give the domain and range of the function, y equals x squared plus 4. So domain, there's no restrictions on what we put in for x. We can put anything we want in. So the domain is x is all real numbers. And then the range, remember we talked about, look at your y-intercept. It's a 4. So we can say that y is greater than or equal to 4. And that goes back to this again here, guys. -3, that was our y-intercept. That's our bottommost point for our graph. So our range started there and went increased. And it's the same idea here. Starts at 4 and increases. And that ends the session.